Hello everyone, welcome to the next class of previous year gate question series. So we were doing Fourier series and Fourier transforms of signal of subject signals and system. So this is your next question. So question says that x omega is the Fourier transform of xt given below. You have to find out the value minus infinite to infinite x of omega whole square d omega rounded off to two decimal places. Now what is this? This is the energy in frequency domain, that is the Fourier transform in energy of x omega, right? Our Parsifal's theorem says that energy in frequency domain is equals to energy in time domain. So we can write it like this. So x omega whole square d omega is equals to 2 pi. Because of omega, we are putting 2 pi. If it was f, we won't be putting 2 pi, right? Minus infinite to infinite x of t whole square dt. Now, this is your signal x of t. Now, what you have to find out the energy. So, energy is always you can find out of a finite signal. So, this is a finite signal, of course. So, this is from present from -1 to 3. But if you observe this signal, this is symmetric about this, right? So it is symmetric about this. So if you shift it by 1 to the left hand side, so your signal will look like this, right? Let me name it YT. So this -1 will be shifted to -2, -1, this is 0, this is 1, and this is 2. This is T. Now why I did the shifting? Because you see that here this and this is same. So even if you find out the energy of this particular part on the left hand region or if the right hand region, so energy of both the regions are same. So if both are same, you can just multiply and find out energy of one side, right? So if we find out the energy of this side energy is also same. So here it is E, here it is also E. So what you can do is find out E and multiply it with 2, so in order to get this total energy, right? It basically does nothing but it reduces your time to calculate things, right? That's the only motto. We have to save as much as like a lot of time in your examination, because some questions might be tricky, some question take a lot of time, right, to solve them, and some question actually does have a lot of calculation in them. So we have to save time as much as possible. So we will solve it now. So we can say that it is also equal to, because I am just shifting it, so it won't change the energy of the signal. So energy of xt and yt is same, right? Shifting operation does not change the energies of the signal at all. So I can say that 2 into 2 pi integration -2 to 0 y of t whole square dt. Right. Now this signal is different, having different slope in this particular, and in this particular area it is having a different slope. So we can calculate slope by easily. So slope is equals to y2 minus y1 divided by x2 minus x1. For this, let me name it point 1, let me name it point 2. So coordinates y2 is -1 minus -2 divided by coordinates of x -1 minus -2, same coordinates. So basically the slope here is 1, right? Similarly, we can find out the slope here and it will come out to be 2. Now, equation of this particular, let me name it 1 and 2. Equation of line 1 will be equal to y is equals to mx plus c is the intercept on y-axis. So m we have calculated, it is 1, so it will be x plus, and the intercept will be, because it is having a slope of 1, so -2 intercept will be 2. 2. Similarly, we can find out the slope of this equation, which came out to be 2. Equation will be here 2 into x plus, and the intercept here is 3. So this will come out to be your equation. Now here x is nothing but t. So let me write in terms of t only. So T. So these are the two equations. We got the equations. Now we can easily divide the integration and put the equation and solve the integration. That's the only thing left in this question. Right, solving the integration now. 2 into 2 pi from -2 to -1. T plus 2 was the equation for first one. Square dt plus from -1 to 0 equation was 2t plus 3 whole square dt. Right. So these were the equations. Now just solve the integration. So this is 4 pi and this integration will be t plus 2 whole cube divided by 3. Limits are -1 to -2 plus similarly 2t plus 3 whole cube 2 into 3 from 0 to -1. So if you solve it, what you will be getting here 1 minus 0 by 3 plus 3 square minus 1 by 6. You can solve it later and that will finally will come up 56 by 3, 56 pi by 3 and the solution is 58.61. So this is your right answer 58.61. Option A will be your correct option. So this was nothing but and that was easy. First concept in this was you have to know this, the energies in both the domains are same. And secondly, in order to ease our calculation, we just shifted it. Otherwise, you can calculate like this also. You have to find out 1, 2, 3, 4 equations. Like we have just calculated two equations, right? You have to find out four equations. So these are the positive slopes and they will come out to be negative slope -2 and -1. And you have to find out the equations and then calculate it. So best way is to just whenever you see a symmetry, multiply it with 2, right? Easy. Next question. So next question says that the input 4 sinc 2t is fed to a Hilbert transformer to obtain YT as shown in the figure. So this is the input and the output is this. Filter is Hilbert transform. Now Hilbert transform basically does not alter the signal at all, right? Hilbert does not change the signal. Signal remains as it is. Only phase is changed by pi by 2 when you are using Hilbert transformer. So magnitude and the shape of the signal does not change at all. So this is your input and this is your output. Now they have defined sinc. So sinc function x is equals to sine pi x by pi x. So this is your sinc function. The value of, again you have to find out the energy from minus infinite to infinite y of t whole square dt output energy. So that will be equal to, so suppose this is your input, so that will be same minus infinite to infinite because it is not changing the signal at all, right? If the signal is not changed, energies are not changed. So energies are basically whenever this, suppose this is a signal and this is a signal, so two different signals will be there, so energy of this and this will be different, but if I am keeping the signal same, so energies will be also same, so energies will be same, and by using passives we can say that energy in frequency domain will also be same. Now why I have converted this into frequency domain, because in time domain this to find out the energy of sync is little tedious because sync curve is like this, it is decaying with time, right? But if I convert into frequency domain, so sync Fourier transform is nothing but a rectangular waveform. So this is the Fourier transform of sync function. So it's best way to convert sync into its Fourier transform. So if I do the Fourier transform of this is nothing but a rectangular function, right? So 4 therefore sink 2t will be equal to the magnitude 4 by 2 sink f by 2. So magnitude was 4. If I am changing the frequency here, so if I am multiplying it with 2, so frequency will be multiplied here and at the magnitude as well. So it will become 2 rect, sorry, this is rect f by 2. So this is your function now. If you plot it, so this rectangular function will look like this. So this is 2 means this is 2. So it lies from -1 to 1. It is always symmetric along the y-axis and its magnitude is 2. So this is how 2 rect f by 2 looks like. So it's easy to calculate the area of this particular region because this is nothing but a rectangular waveform. So from minus infinite to infinite, x of f whole square d of f is equals to, this is 2 and the area will be 2 whole square. So that will come out to be 8. So this is your area of the output as well. So it comes out to be 8. Very easy question.